Hello, friends. All right, today we are going to go into our journals. So open up your journal. We should be on Unit 5, Lesson 1. So go ahead and go to Systems of Equations, and we're going to talk about systems. So, like I said yesterday, everything we're doing in this unit we've done before. The only thing we're changing is this idea of systems. So, what is a system? What is a system of equations? We updated this link to where you don't have to delete out the text in there. You can just click and start typing. So, what is a system? A system is two or more equations of similar variables. So, this means we have two or more equations with x and y, or two or more equations with a and b. But they have similar variables, and we have two equations. So we might have two equations that look like y equals mx plus b, where our m and our b are different, okay, or where they're the same. So what type of solutions do we have? Well, we have one solution, and this is going to look like x, y. This is going to be an ordered pair. So this is going to be one single point where the two lines cross, where they intersect, where they're exactly the same. We can have two solutions. Oh, I'm sorry. What am I thinking? Sorry. One solution. We can have no solution. Let me put a comma here. No solution. So this would look like they don't cross at all. These two lines do not intersect at all. Actually, let me put in parentheses here. This would look like parallel lines. You have parallel lines, and there's going to be no solution there. And then you can have infinite solutions. And this is going to look like two lines that are exactly the same. So we have some examples here. When we have one solution, we're talking about systems. So that means we have two lines. So here's one line, here's two lines. Our one solution is that blue point where they cross, the intersecting point. When we have no solutions, we have two lines that are parallel. See, these two they never intersect. They're not going to touch. So there's no solution. There's no answer where they're both the same, where they touch each other. And then infinite solutions would be this situation where these two lines, there's two lines here, but they're right on top of each other, so we don't see any difference between them. Okay, so let's go ahead and look at slide 25. So we want to solve by graphing. So on number 1 here, we have two equations that are already in the form y equals mx plus b. So what I want to do is I want to go to Desmos. So I'm going to come over here. I'm going to click on the Desmos link. So on your screen, you should click on Desmos, open a new tab. This is the Desmos you should use every single day. This is the version you're going to be able to use on STAR. If you start getting used to using the online version of Desmos, you will not know how to do things that you're going to need to know how to do for the STAR test, okay? Oops, sorry. Let me close that out. Here we go. All right, so I have two equations that look like y equals mx plus b. So I'm going to type these two equations into Desmos. So my first one is, sorry, where am I at here? Y equals negative x plus 8. So y equals negative x plus 8. And my next equation is y equals 3 halves x minus 7. So y equals 3 halves x minus 7. Okay, so it graphed my two lines. Remember, my solution is where they cross. So in Desmos, it gives me that point. I can just click on it. It tells me the answer. So my solution here is 6, 2. So next to solution right here, I'm going to put the ordered pair 6, 2. I'm going to stretch this out a little bit so it'll fit up here. That's it. So on number 2 here, my two lines are already graphed. So what I'm looking for is where do they cross? Well, they cross right here. And what's that ordered pair? Remember, I have to go into the elevator before I can go up. So I need to go to my x first. So I go to -1 and up to 3. So my solution here is going to be -1, 3. I'm going to make this box just a little bit bigger. -1, comma 3. There we go. That's our solution. Number 3, we also have a graph. So I'm looking for where they cross right here. So I go to 2 and down to -7. Oops. What is happening? Why are you not letting me click? There we go. 2, -7. All right, so on number 4, let me make sure this is open. Okay. On number 4, the first equation is written as y equals mx plus b. So I can go ahead and graph that in Desmos. It's y equals -3x plus 8. Y equals -3x plus 8. It'll graph that line for me. However, the second line is not in the form y equals mx plus b. So I need to change it to be in the form y equals mx plus b. All right, so let's go ahead and do that. We have to solve to get y by itself. So the equation is 6x plus 2y equals -10. I need to leave this piece right here by itself. So I'm going to go ahead and move 6x to the other side. Remember, I'm subtracting 6x because this is a positive 6x. To undo something positive, I need to subtract. So my goal when I'm moving it away from this side is to make it go away. So positive 6x minus 6x is 0. All I'm left with on this side is 2y. Okay, so that's why I subtracted it. I want it to get to 0. -10 and -6x are not like terms. So I'm just going to be left with -6x minus 10. And divide both sides by 2. When two things are right next to each other, this 2 and this y are right next to each other. It's multiplication. To undo that, I have to divide. Then 2 divided by 2 is 1. And I'm just left with y. So then over here on this side, I have -6 divided by 2 and -10 divided by 2. So -6 divided by 2 is -3. That's being multiplied by x. -10 divided by 2 is -5. So this equation in the form y equals mx plus b is y equals -3x minus 5. Well, now I can graph that into Desmos. So y equals -3x minus 5. All right, so these two lines look like they're not going to intersect. I can zoom out a really, really far. Well, eventually get on top of each other. I can move up and I can move down, and it doesn't look like they're going to intersect. As a matter of fact, it kind of looks like they are parallel. But what do we know about parallel lines? They have to have the same slope. Do my two lines have the same slope? Yes, they do. So these two lines are parallel. And we set up here on slide 24 that if they were parallel, that means they have no solution. So down here, I can say that these two lines have no solution. Right? All right, so there is an activity. I want you to go to modules and scroll down to unit 5 all the way at the bottom. We are on yours. This should be the last thing you guys see. Solving systems of equations. This is a Google Cloud assignment. So remember, you'll have to click this blue tab right here this blue link that says self-correcting systems. Otherwise, it's really, really tiny on your screen. So open that up. And it will open this in a new tab so you can work from it. And you're going to put the solutions in here. Again, all the yellow boxes, we've done assignments like this before, all the yellow boxes will turn green when you get them correct, okay? So I will do number 1 with you. We can graph this in Desmos. Y equals 7x plus 4. So let's go ahead. Y equals 7x plus 4. My next problem is y equals x minus 2. So I have y equals x minus 2. these two lines cross, and they cross at -1, -3. So right here, I'm going to do -1, -3, and hit enter. It turned green. That means I got it correct. Okay? So let's see. Let's do another one. I'm going to do, I think all of these right here, like this, these are already in the form y equals mx plus b. All you have to do is type those in Desmos. On number 5, you're going to have to solve this one for y. Get y by itself. These are in y equals mx plus b. All of these are, let's see, 9 and 10 are in y equals mx plus b. 11. I'm going to do 11 with you, and then I'm going to let you guys do the rest. So I'm going to do 11 with you. Let's see. Let me pull my iPad back up. Slide it this way. All right, so let's do number 11. We have x minus y equals 3. So I want to leave y here by itself. That means I need to move x. So to undo something positive, I'm going to subtract it on my line here. X minus x is 0. I just have negative y equals negative x plus 3. This is a positive 3. That's why I have plus 3. Okay, the sign goes with the number behind it, so that negative sign goes with the x. All right, y is still not by itself. I need to divide by -1. So -1 divided by -1 is just y. Negative divided by negative is just x. Positive 3 divided by -1 is -3. So this is my first equation. Then we have this second equation that looks like 8x minus y equals -4. Let me just drag this over just a tiny bit so you can see. Draw my line. Again, I want to leave y here by itself, so I'm going to subtract 8x from both sides. 8x minus 8x is 0. I just have negative y. Then I have negative 8x minus 4. There's a negative sign here and a negative sign here, so both of those have negative signs with them. Oops, I'm still not on the screen all the way. There we go. Y is still not by itself. I need to divide by -1. So negative divided by negative is just y. Negative divided by negative is positive 8x. Negative divided by negative is positive 4. 4 divided by 1 is just 4. 8 divided by 1 is just 8, right? All right, so my two equations are y equals x minus 3 and y equals 8 minus x. I'm sorry, 8x plus 4. My goodness. All right, so let's go ahead and type these in. Y equals x minus 3. Y equals 8x plus 4. These two lines cross at -1, -4. So right here, I'm going to put in -1, -4. Make sure you put the parentheses around the numbers, otherwise it's going to tell you it's wrong. Okay? All right, so I'm going to let you guys do the rest of these by yourself. Remember, they'll turn green if you got it right, so you can check yourself as you go. All right, if you have questions, please email me. Let me know. I'm more than happy to help you. See you later.